For centuries, the forest was seen as a battleground, a place where trees stood tall in silence, competing fiercely, living and dying in dignified crunches beneath their neighbors. Trees were solitary survivors, locked in evolutionary duels for light and life. But that perspective began to shift, slowly but surely, thanks to a growing number of curious scientists who were willing to dig deeper. Literally. What they discovered, both metaphorically and with actual shovels, fundamentally reshaped our understanding of trees, forests, and even the concept of communication itself. One of the pioneers who led this scientific revolution is Dr. Suzanne Simard. As a young forester working in the dense, damp woodlands of British Columbia, Canada, Dr. Simard began noticing strange patterns. Young trees often thrived beneath certain older trees, not just randomly, but in ways that couldn't be explained by sunlight or soil alone. Some saplings seemed to flourish in areas where, on paper, they should have withered. The traditional model of every tree for itself didn't quite add up, and so she asked a deceptively simple question. Could trees actually be helping each other? To find the answer, she designed an experiment that would make most gardeners raise an eyebrow. She selected two distinct tree species, paper birch and Douglas fir, natural neighbors in the forests of Canada. She planted them together in a controlled forest plot. Then she exposed one of the birches to carbon dioxide labeled with a radioactive isotope, so she could track where the carbon went. What happened next was astonishing. The radioactive carbon didn't just stay in the birch, it traveled underground, through the roots, through the fungal network, and showed up in the Douglas firs nearby. The trees were literally sharing carbon. And this wasn't a one-way exchange. Later, when the Douglas firs were in better health, they returned the favor. The relationship was mutual. This wasn't a forest of isolated competitors. It was a living, breathing community. And just like that, a new understanding was born, one that challenged decades of forestry dogma. Dr. Simard's work showed that trees communicate, collaborate, and form social networks not unlike our own. They share information, balance resources, and support one another across species boundaries. Dr. Simard coined the term mother trees to describe the largest, oldest trees, those that serve as central hubs in this underground web. These trees aren't just feeding their offspring, they're shaping the entire forest. They recognize kin, allocate resources strategically, and influence how the next generation grows. At Infinity Beyond, we often highlight scientists who expand our view of the universe. And Dr. Simard is one such visionary, not by gazing at the stars, but by looking at the roots. She helped us realize that intelligence doesn't have to be fast or noisy. It can be slow, silent, rooted in the ground and spread out through tendrils of cooperation. Her research was met with resistance, of course. Many scientists were skeptical. After all, the idea that trees talk and help each other sounded like science fiction. But as more studies emerged, the evidence grew undeniable. Dozens of peer-reviewed papers now support her findings. And the idea of the Wood Wide Web is becoming mainstream. And it's not just an academic exercise. Dr. Simard's discoveries have major implications for how we manage forests. Clear-cutting, removing all trees from a plot, doesn't just erase vegetation. It disrupts the entire communication system. When mother trees are removed, forests lose their wisdom centers. Saplings struggle more. Biodiversity drops. Recovery slows. But when mother trees are preserved, the forest rebounds faster, guided by the invisible connections still humming beneath the soil. Simard's work also underscores the importance of forest diversity. Birch and fir may be very different trees. One deciduous, the other evergreen, but they benefit each other. Mixed forests, it turns out, are healthier, more resilient, and more adaptive to change than monocultures. That means if we want to preserve forests in a changing climate, We need to protect not just the big charismatic trees, but the relationships between them. Dr. Simard is also passionate about changing how we talk about nature. She believes, and rightly so, that terms like mother, communication, and sharing aren't just poetic metaphors. They reflect real behaviors, measurable and observable, even if they don't follow human logic. Nature doesn't fit neatly into our boxes. Sometimes it takes empathy to see the science. So the next time you walk through a forest, remember the story of Suzanne Simard. Look beyond the trunks. Imagine the networks beneath your feet. Picture carbon flowing between neighbors, warnings pulsing from root to root, wisdom passing down through generations. The forest is alive in ways far deeper than we ever knew, and it took a determined woman with a curious mind to make us see it.